10.1 is a very short section on graphing data. I think there's only 3 homework problems on this section, and I'm fairly confident that you already know how to graph data, how bar graphs work, how line graphs work, and how pie graphs work. So we'll just go very quickly through this. I'll just do 2 examples. Here's the first one. Here I have some data behind me. It's the data of U.S. Postal Service employees, the number of employees by year. And we have some data here. So in 1990 there were 760,668 employees. Going down the line, in 2015 there's now 491,863 employees. And we want to display this data graphically. So what I'm going to do is I'm going to make a graph here. And I think on the x-axis I'll plot the years. So our first plot here will be 1995, and we'll just evenly distribute these. Next one will be 2000. Next one 2005, 2010, and 2015. So it looks like is that all I have? Oops. Sorry, bear with me while I relabel these here. We started at 1990. There we go. 1990, 1995, 2000, 2005, 2010, 2015. Alright, and on the y-axis, so let me label this. This is years, or the year. And on the y-axis, let's do number of employees. I need to choose a scale. Since I never go below 400,000, I could potentially just start this at 400,000 and leave the rest off. But I think I'll start at 0. I'll start at 0, and how about we just jump by hundreds of thousands? So this would be right here. We'll call this 100,000, 100K. Then we'll do 200,000. Then 300,000, 400,000, 500,000, 600,000, 700,000, and we never go above 800, so I'll stop there. We'll do 800K. Alright, so now I just want to plot these points. I'm essentially plotting discrete data on this graph. So in 1990, we have 760,000 employees roughly. So 1990 coming up here, 760,000, that would be somewhere just a little bit about halfway between 700 and 800. So maybe we'll plot the point right there. All right, so for 1990, that's about 760,000. And we'll just plot this for all of these. So 1995, we're at 753,000. So that is, by the scale, that should be almost in line with it horizontally, but just a tiny, tiny, tiny bit lower. So we will plot it right there. Almost imperceptible how much less it is, because it's a very small number in terms of difference. Then 787,000 in 2000. So go to 2000, and we'll plot this one a little bit higher, very close to 800,000. 2005, we're now down to just about 700,000 on the dot, so we'll come up to 700,000, looks like it's right around here. This is why, by the way, I thought maybe I should just start my scale at 400,000, then I'd have more space to work with and I'd have a more perceivable difference between these points, because the scale would be a little bit larger, but this is fine so far. Where are we at? Now we're at 2010. Now we have a significant difference, just a little bit below 600,000. 2010 will come up, 600,000 about here, so there we go. And last but not least, 2015, just a little bit below 500,000. Probably right around here. By the way, you can do other things. You could sort of drop like a dotted line or something if you want to keep track of exactly which value these correspond to. But these are all just sort of visual references, visual aids. So anyway, I've plotted my points, and there's a couple things you can do to make this stand out a little bit more interestingly than just these points here. One thing you could do is you could play connect the dots, right? I could draw straight lines between successive dots that really sort of give some reference, give some visual indication as to whether you're increasing or decreasing as the years go by. So if I connect these points with linear segments, you get some sort of visual indicator as to whether you're increasing or decreasing as time passes. And if you do this, forget about these things for now. If you do this, this is what the textbook calls a broken line graph. And it's one very common way to plot data, or to graph data visually, is just by constructing these broken line graphs. Something else you could do is you could construct a bar graph. And that's just taking this exact same data and coming in here and representing it slightly differently visually, which is for every single one of these points that I've got plotted, I'm going to build a visual bar corresponding to it, whose height is given by the point. So, for example, this point, I construct a bar. Next point, once again, I construct a bar of that height. And I'm just going to leave a little bit of space between these bars for aesthetic reasons. Next point, I've got, it's up here, so once again I constructed a bar of that height. And we'll just finish this off. Always just go to your points and construct a bar whose height is given by that point that you plotted. I've started shading that in the opposite direction. Let's not do that. We'll be consistent here. You can make your bars change colors if you want, you know, make it a little bit more pretty. But here I'm just going with a red bar for all of them. They should all be the same width, but, you know, I'm drawing this freehand. But now I've got the data visualized using bars. And the bars are also nice because you can sort of see by the size of the bars, by the height of these bars, how the population is changing relative to each other over time. And if you plot your data like this, this is called a bar graph. Doesn't always have to be vertical like this. Sometimes you'll see horizontal bar graphs. Sometimes you'll see data that's best displayed using 2 bars for each point, double bar graphs. But yeah, I'm sure you've worked with bar graphs in the past. I'm sure you sort of anyone could give you a bar graph and you could read off the data because you're familiar with working with these. So that's really all I have to say about bar graphs. Now let's move on to pie graphs. Next up, we've got an example on gasoline prices. So in April 2017, the average price of a gallon of gasoline in the United States was $2.47. Of this amount though, so breaking down this price into different pieces, of this amount, $1.26 was the cost of the crude oil alone. 57 cents of it was the cost of refining that crude oil. 20 cents was the cost of distribution. There's some marketing in here too, but 20 cents was the cost of distribution. And 44 cents was the amount of tax that's going into this $2.47 price. And the first thing I want to do is I want to figure out the relative percentages. I want to know what percentage of the cost was the cost of the crude oil, the cost of refining, and so on. So let's do this really quickly. percentages. So let's see, crude oil. What's the percent of this cost that's crude oil? Well, it's $1.26 over the total, $2.47. And I plug this into a calculator, I get 0.51 or 51%. All right, next up we've got refining. So 57 cents, 0.57 over $2.47. Again, I plug this into a calculator, I get 0.23 or about 23%. Distribution. We've got 20 cents, 0.20 over 2.47. This came out to about 8%. And the tax, what is it, 44 cents over $2.47. I got 0.18 or 18%. So I'm going to visualize this graphically using a pie graph. And a pie graph is, well, you just take a circle and you cut the circle into portions that represent the relative percentages. So for example, if this entire circle, this entire pie, represents the entire cost of a gallon of gasoline, 51% of this pie, of this circle, is the cost of the crude oil. So 50% is of course exactly half. 51%, usually you start here, so here's my 12 o'clock line. 51% would be just a little bit more, just a tiny bit more than coming straight down, an extra percentage there. Oops. For starters, this isn't entirely vertical. Let me just redraw this. I'm not happy with this. Alright, there's my circle, 12 o'clock line, something like this. And straight down, tiny bit off of straight down. There we go. There's the crude oil, and that's 51%. Next up, we've got refining, 23%. 23 is just ever so slightly less than a fourth of the circle, a fourth of the pie, and so just ever so slightly less than a fourth. 51% plus 23% would be 74%, so I'll just come just ever so slightly less than 9 o'clock here, and here's refining. So this is 23% of the pie. And next up we'll just eyeball this. Distribution 8%, tax 18%. I've got 26% left of this pie. 8% is about a third of it. So we'll slice it maybe like this. We'll say this is distribution, which is 8%. And the last bit is tax, which is the remaining 18%. And if you want, you could make your picture more pretty. Sometimes you'll see it shaded, so I'll shade it different colors. Crude oil's in red. Refining, I'll shade this in yellow. Distribution, I'm running out of colors, so we'll shade that in white. And tax, we'll shade that portion in green, just to make it entirely clear which portion is which. So sometimes you'll see pretty colors like that. And I believe there's a homework question that asks you exactly what the angles here should be. So for example, if I wanted the tax, if I wanted to know what this angle here is, well, there's 360 degrees in a circle, right? This tax portion makes up 18% of the circle, so it should make up 18% of the 360 degrees. So I would just take 360 degrees and multiply it by 18%, 0.18. And if you do that, plug that into a calculator, I get 64.8 degrees. Alright, so I drew this just by eyeballing it. I was eyeballing sort of the relative portions to each other, but if you want to do this very precisely and have the perfect angles here, the exact angles corresponding to each segment, you just take 360 and multiply it by the relevant percent. So you can do that for all of the rest of them. For example, if you want to know the angle here for crude oil, 360 times 0.51, etc. Otherwise, that's, like I promised, it's a very short section. That's the end of it. Thanks.